this lesson on the math of finance, our goals are to apply correct compounding interest formulas and use the finance application on your graphing calculator. First, we're going to start with some vocabulary. The principal is the initial amount invested or the initial cost and is denoted by P. Compound interest is interest that becomes part of the investment or interest that is earned on the interest itself. Annual percentage yield, or APY, is the percentage rate that compounded annually you would yield the same return as the given interest rate within the given compounding period. Annuity is a sequence of equal periodic investments or payments. Present value of annuity is the net amount of money you put into an annuity or the amount of a loan. The future value of annuity is the net amount returned from the annuity and includes all payments and interest, or the amount still owed on the loan at some future time. Now let's look at some useful formulas. Our first one is for interest compounded K times per year. Here, our A is our final amount. Our P is our principal amount, or the amount you start with. R is our rate as a decimal, so this will be our interest rate. Then we have K, which will be the number of times per year that our interest is compounded. And then finally, we'll have our K times our T, which is our number of years. Now, for K, when we say K is compounded annually, or our interest is compounded annually, our K equals 1. If we were to do it quarterly, this would be 4 times a year, and our K would equal 4. Now, if we want to do monthly, K would be 12. If we did daily, K would be 365. So now let's look at some examples of using this formula. Determine how much time is required for an investment to double in value if interest is earned at a rate of 5.75% compounded quarterly. So first, we want to see how much it doubles. We know our interest rate is 5.75%, and we know it's compounded quarterly. So, using our formula, we want to see when it doubles, so our final amount is 2 times our original amount. Then our original amount, which will be our principal, times 1 plus our rate converted to a decimal, 0.0575, over our number of times compounded per year, which is quarterly, which would be 4, raised to the K, which is our times compounded, times time. So now we want to see, now we're going to solve for time. So we can simplify a little bit. We'll have 2 equals 1.014 raised to the 4t. Now we can take the log of both sides. So the log of 2 equals the log of 1.014 raised to the 4t. Here we will use our properties of logs. We'll have log of 2 equals 4t log of 1.014. And now we can divide by log of 1.014, and we'll be left with 48.565 equals 4t. And then we can divide by 4, and we can see t equals 12.141 years. Remember, t is always in years. So now let's look at another formula. Here we have interest that is compounded continuously. So we still have our final amount, our principal, our rate, and our time. So let's look at an example where interest is compounded continuously. Find the value of an investment with a principal of $3,350 at 6.2% compounded continuously for 8 years. So we're going to use our new formula, and we'll have our final amount equals our principal, which is $3,350, times e raised to our rate as a decimal, 0.062, times time, which is 8 years. And we can put this in our calculator, and we will end up with 5,501.168. So we can round so that we're actually using monetary units, and the investment after 8 years will be worth $5,501.17. So now let's look at another way to solve these problems. We can use our calculator using the finance application. This finance application is called the TMV Solver. TMV Solver stands for time value of money. It solves for one variable when given values for any 4 of the 5 remaining variables are given, especially useful for car payments and other loan payments. To get to the finance application, you're going to press Apps, and then Finance, then TMV Solver, and then you can begin. Our N is our number of compounding periods total. I% is the annual percentage rate and is always written as a percent. Present value of the current account or investment is PV. PMT is the payment amount. FV is the future value of the account or investment. P/Y is payments per year. C/Y is compounding periods per year. And for our use, C/Y and P/Y will be equal. Payment end begin means the payment is made at the end or the beginning of the payment period. Note, you must enter any money that is received as a positive number and any money that is paid out as a negative number. Let's try some examples. For our first example, Sal opened a retirement account and pays $50 at the end of each quarter, 4 times a year, into it. The account earns 6.12% annual interest. Sal plans to retire in 15 years. How much money will be in his account at that time? So we know that he pays $50 into the account at the end of each quarter. So this means 4 times per year. The account earns 6.12% interest annually. And he plans to retire in 15 years. So we want to find out how much money will be in the account at that time. So we know it's compounded quarterly, so this will be 4 times the number of years, be 15. So this is the number of times interest will be compounded. Our percent will be left as a percent. We'll have 6.12%. The present value of the account is 0 because he just opened it. He's going to pay $50 into the account every single time. So since he's paying the money into the account, we're going to put -50 for payment. We're going to try and find future value. Our payments per year are 4 times per year, which means compounded 4 times per year. So, now to put this into the TMV solver. First, we can put in our N, 4 times 15. Then our percent is 6.12%. Payment values, nothing right now. Payment is -50 because he's paying into it. Future value we're going to leave as 0 just for a moment. Then payments per year is 4, and then compoundings per year is 4, and it's made at the end of the month. To solve for this, we're going to press alpha and then enter. And we can see that the future value of the account will be $4,859.24. So after 15 years, paying $50 at the end of each quarter, Sal will have $4,859.24. Let's try another example. Kim wants to buy a used car for $9,000. The bank offers her a 4-year loan with an APR of 7.95%. What will Kim's monthly payment be? We're going to assume that she makes her payment on the first of each month. So, we know she wants to buy it for $9,000. This will be our present value of the loan. We know the interest is 7.95%. We know we want the future value to be nothing. And we know it is a 4-year loan. So we're going to say 4 times 12, because it'll be compounded monthly, because she's making a monthly payment. Our payments per year will be 12, and compoundings per year will be 12. And since she'll be paying at the first of each month, we'll have to make sure to change our payment here from end to begin. So what's this look like in the calculator? We're going to have 4 times 12 at a rate of 7.95%, with a present value of the loan being $9,000. We don't know her payment yet. The future value, we want the loan to be gone. Payments per year is 12. Compoundings per year is 12. I'm going to change this to begin. Don't forget to change it to begin if stated this way. So now, to solve for her payment, we're going to go highlight the payment, hit alpha, and then enter. And we'll see that it'll be $218.06. It is negative because those are going to be her payments per month. Now, the reason end and begin is so important, see what happens when we pay, if she would pay at the end of the month. If she paid at the end of the month, her monthly payments, we're going to do alpha, enter again to solve, would be a little bit higher. They'd be $219.50. 51 cents actually. So it'd be much wiser to pay at the beginning of the month than the end of the month. So let's try 2 more examples. Our first one is dealing with compound interest again. And we have $100 is deposited in a bank at 6% annual interest for 5 years. How much will the balance be at the end of the 5th year if interest is compounded both annually and monthly? So let's look at the difference of how interest rate compoundings affect our total at the end. So for our first one, if it's compounded annually, be 1 over the 5 years times 5. Interest is 6%. Our present value is negative 100 because she deposited that money in, so she paid that money into the account. Our payment is going to be 0. We're not going to make any payments on this account. Our future value is what we're trying to find. Payments per year and compoundings per year will be 1. So doing this, be 5, 6, negative 100, 0, 1, 1. And we want to find the future value of the account, so we do alpha solve. And we'll see that the future value will be $133.82. Now let's see how this changes if interest is compounded monthly. So our number of compoundings is going to be 12 times the 5 years. Still 6% interest, still initial payment of $100. Still no payments are made. Payments per year is now 12, and compoundings per year is now 12. So now, all we had to change here was our n, be that 12 times 5. Everything else remains the same till our payments per year. Oops. And then here, solve for future value, alpha, enter. And we'll see that the future value of the account is $134.89. So this means that the more times a year interest is compounded, the more money you earn. So it's good to find a bank savings account that compounds more often. Let's try one last example. This is on savings. So suppose when you were born, your grandparents deposited $5,000 in a special account for your 21st birthday. The interest was compounded monthly at 5% interest. How much will the account be worth on your 21st birthday? So let's look here. We know it's going to be compounded monthly, so it'll be 12. And it'll be, we want to find out when it's worth on your 21st birthday. And it was started when you were born, so that'll be 21 years. The interest is 5%. The present value is what your grandparents deposited, so it was negative 5,000. Because they put that money into the account, it was paid out. There's going to be no payments made into the account. We want to know the future value. Payments per year is going to be 12. Compoundings per year is 12. So we'll put this in the calculator. 12 times 21. So it'll be 252 times compounded. 5% interest. 5,000 initially in there. Nothing added. 12 and 12. And then we're going to highlight the future value again because this is what we want to solve for. I mean, payments, there are none made, but we're just going to default at the end of the month. I'm going to hit alpha and enter. And we'll see that on your 21st birthday, this account will be pretty large. You're going to have $14,000, $14,257.12. That's a pretty good savings account. So it's important to remember there are two formulas and how to use our finance app. Both of them would be very useful in solving for various things. Now we just solve for payment and future value on the finance app, but you can also solve for other things, including interest rates that you can afford. When you're doing a car loan, you can do monthly payments, future value, and other things like that. So that is it for this lesson.